Good morning to one and all. Myself Tulsi. I am here going to explain about BFS. BFS means breadth first search. BFS is an algorithm that is used to graph data, search tree, or traversing structures. Means, for example, we take this graph. From this graph, we have to find the shortest path. For that, we have to use BFS and DFS. For BFS, we use Q. Q means first in, first out. Algorithm for BFS start by putting any one of the graph vertices at the back of a queue. Take the front item of the queue and add it to the visitor list. Create a list of that vertices. Adjacent nodes, add the one which are not in the visitor list to the back of the queue is empty. From this we have to see that we have to take first element and we have to add to the queue, and we can see that take the front item of the queue and add it to the visitor list. Then it will have to write it in the visitor list. The vertices of the that first node we have to write again, we have to add in the queue, and this process will continue until the queue is empty. We can understand by seeing this example. We can see this is an example. We are writing here nodes means A, B, C, D like this, and the adjacents of A, we can see that the arrow mark A to F, it's showing that A to F means A. For A, F is an adjacent, and for A, C is an adjacent. For A, B is an, we write in here. For A, F, C, B are adjacents. For B, we can see that C and G are adjacents. We written here. For C, we can see only F have. From C to F only one element is F, that is F. For D, we can see that C is an adjacent. For E, we can see that C, D, J. From E, we can see that C, D, J are adjacents. For F, we can observe that only D is an adjacent. For G, we can see that C and E are adjacent. For J, D, K and K is EJ. For like that, we have to write from the graph. We know that Q, we use Q in BFS. Q means first in, first out. First visitor list is null because the queue is empty. There is no element. The first element we added to the queue, and the first element is added A. Front and rear in this time front and rear are equal because all are first element. Once we added to the list first in, first out means A will come out because it is an visited element, so we can write it and visited list A. The adjacents of A are FCB, so FCB are added to the queue. Then the F is an front element and B is an rear element. The front element are deleted first, means that will list first, and the A and F are become as visited list. Then you can see that for F we have D and adjacents. We added D as an adjacent in last because we know that first in, first out, and means first in, first out means first which element are added to the queue that will come out. The remaining adjacents should be added in the backside of the remaining elements. C. After that F we have the adjacent is D, so we added D. For C, now we can see C is an first element, so we have visited C first. It will deleted. The adjacents of C are F. The F is already in visitor list. Once we visited the elements which are in the visitor list, we cannot write it again. The elements which are in the queue, we cannot write it again. One time only we have to write. So A, F, C are visitor list from this. Now B is an first element, so B will come out. B have C and G. C already in the list, in visitor list, so we didn't write. So G we have to write. G is added at the back, D back. Now front element is D. We have to remove, we have visited D, so this D will come out. Then D adjacents are C. C is already in the visitor list, so we didn't add. So D will come out. A, F, C, B, D are visitor list. For G we have visitor list only one element, it will come out. The adjacents of G are C, comma E. C is already in the visitor list. E, you have to add E. We add E. Now E is a single element. We have visited E and it will come out. For E we have C, D, J. C, D, J. C and D already in the visitor list. We can see that C and D. So we didn't add C and D. J we have. For J, it is a single element, it will come out in visited list. For J, we can see that DK. D is already in the visited list. So K we had K, and the K is removed. There for K we can see that EG. EG already in the visited list. We can see that EG. So we didn't write that. The like that we have to repeat the process until the queue is empty. Now we can see that the final list is A to F, F to C, F to B. We can see that A to F, F to C, F to B, F to D. Like that we have to repeat the process until the queue is empty. For directed graph we can do this and easily. Once we take another example which was an undirected, means like this. We can see the difference between two graphs. It has a direction, means A, F, only F. F didn't have A as an adjacent. A node has F adjacent, but F not have A as an adjacent. For this we can see that for A we can see F, C, B, and for F all F has A, C, D, like that. And C we can see that A, B, F, D, E, G, and B we can see that G, C, A. For D we can see that F, C, E. For E, C, D, G, J, K. For G, B, C, E, K, J, D, E, K. For K, J, E, G. From this we can observe that A has F, C, B, F has only D in this adjacent. From this A, C, D, because there is no direction in this graph. So these all are adjacencies for these nodes. From this we can write that Q. Q means first in, first out. First in Q we can add A element. From this we have 9 elements. No, we have created 9. A. From A is a friend and rare element. A will come out because it is an visited element. A is come out. So in visited list A, then the nodes of adjacents of node A are added to the queue, means F, C, B are added. In this we can see that F will come out. So now visited list is A, comma F. After that we can see now that the changes between two. F is come out. The adjacents of F are A, C, D. You can see that A, C, D are adjacents of node F. Already A is in visited list, C is in the stack, and D will come. D is added to the list. Now F and R. C is an first element. So first in, first out queue, we know that. So C will come out. Now the visited list is A, comma F, comma C, and after that we have to add the we have C. We can see that A, B, F, D, E, G are the adjacents of C. So we have to add that. But A is already in the visited list, B is already in the queue, and F is already in the visited list, D is already in the queue. Now we had E, comma G only. So this is F, this is A. B is come out because first in, first out, visited list A, comma F, comma C, comma B. For B we can see that G, C, A. G is already in the visited list, in Q and C is already in the visited list, A is also in the visited list. So we can write from this D, E, G. E, G means D will come out first element. So now visited list is A, comma, F, comma, C, comma, B, comma, D. Now for D we can see that F, C, E. F is already in visited list, C is already in visited list, E is in the stack in Q. So now we can write it is an friend and it is an, so first element will come out, E is come out. Now visited list become A, F, C, B, D and E. For E we can see that C, D, G, J, K. C is already in the visited list, D is also in the visited list, G is in the stack. Now JK is added to the Q. Then Q becomes and then G, J, K. Now G is an first element, K is an last element. So G will come out. So now visited list become A, F, C, B, D, E, G. Now for G we can see that B, C, E, K. B, C already in the visited list and E also in the visited list, K is in the stack. So now it becomes now J, K. J is an front element, it is an red. So J will come out. Now the visited list is A, comma, F, C, B, D, E, G, J. For J we can see that D, E, K. D E already in the visited list and K is in the stack. So no element we added. K. Now K is only front element and K is only last element. So K will come out. A, F, C, B, D, E, J, K. For K we can see that J, E, G. J, E, G already in the list. So now Q becomes an empty. So the list we can see that the list is A to F, F to C, C to B, D, G, E, J, K. From this, for undirection also we got the same answer. For direction graph also we will get the same answer. But the adjacent of the node will be increases. That's the difference between these. We have to repeat this process until the stack is an empty. That's it. Thank you for giving this opportunity.